Welcome to the Teaching of Fractions series, a step-by-step way to show teachers how fractions should be taught at the Standard 3 level. Let us begin with the teaching points that all Standard 3 teachers should be teaching. All Standard 3 teachers should be teaching the basics of fractions. By this we mean the representation of fractions. They should also teach equivalent relationships, reducing fractions in its lowest equivalent form, proper fractions, improper fractions, and mixed numbers, fractions placed on the number line, and addition and subtraction of fractions. In the latter case, the denominators are the same. Before representing fractions, teachers should review fraction names and show how they are represented. They must indicate the name of the number to the top of the line and the bottom of the line. They can also include the name of the line that separates the number on top from the number below. That is called the vincular. Then, the teacher should demonstrate contextual meaning of a half. For example, if someone had 10 marbles, then this 10 marbles is considered as the whole. If the person gives half of the amount to someone, then this will be the amount given. This therefore represents 1/2. 5 is a half of the whole. Contextual meaning can also be derived from a line. If a line has the length between 0 and 1, this can be considered a whole. Half of the line is the midpoint between 0 and 1. The area occupied by this rectangle can be considered the whole. Half of the area covered by the rectangle is represented by this. These are 3 fraction models. In fact, they are the 3 fraction models that teachers are expected to impart to their students. The first model is called the set model. The second is called the linear model. Linear takes its name from straight line. And the third is called the area model. Before getting into equivalent relationships, teachers should encourage their students to satisfy their mathematical curiosity through investigation. This investigation commences with the use of manipulatives. For example, if you had 1/2, the teacher can ask the students to find out how many quarters is equivalent to 1/2. The students will then, through trial and error and self-discovery, find out that 2/4 make a half. Teachers should then encourage the students to represent their findings symbolically. In this case, it's represented as 2/4 equal 1/2. At least 3 similar exercises should be given. One more is done for you. Here, symbolically, this represents 3/6 equal a half. Whenever concepts are taught, it is important that teachers provide non-examples. Let us use our fraction tiles to provide a non-example. Here we have 5/6, and this is 3/4 or 3/4. Clearly we can see that 3/4 is not equal to 5/6, simply because they do not cover the same area once all the gaps are filled. We therefore represent this symbolically by saying 5/6 is not equal to 3/4. These equivalent relationships that the students have discovered can help the students lead to the algorithm for creating the equivalent relationships. For example, they had discovered that a half is equal to 2/4. The teacher can then ask the question, what number can I multiply 1 by to give me 2? Then they ask the question, what number can I multiply 2 by to give me 4? After providing the answer, students can then be asked what they observe. The same pattern can be expressed for the other equivalents that the students have already derived. For example, you may have a half is equal to 3/6. This was one of the examples that they would have already done using tessellation. The said question can be asked, what number do I multiply 1 by to give me 3? And what number do I multiply 2 by to give me 6? After providing the answer, the students are then asked what pattern do they realize. The students should be encouraged to look at the first example and the second example to see if they notice any commonality. Then another equivalent relation may be given and the same questions asked, and then the students will be asked to confirm if their observation is accurate. Here, they should have realized that to create the equivalence, you would have had to multiply the numerator and the denominator by the same number. Teachers should also be encouraged to do the reverse. That is to say, we start with the 2/4. So we say 2/4 is equivalent to a half. We can point the students in the direction of what possible operation can take us from 2 to 1. It has reduced. So we can ask the students, what number do I divide 2 by to give me 1? And what number do I divide 4 by to give me 2? After providing the answer, the same situation is applied to the other examples. The students, through observation, would observe that in every instance, to get the equivalent, you had to divide both the numerator and the denominator by the same number. This, therefore, will be the algorithm for creating equivalence. So, in fact, students will be exposed to two abstract ways of creating equivalence. This particular way is called reduction. Now that students are aware of how to create equivalent relationships using an algorithm, teachers can now venture into ordering equivalent relationships with more than 2 fractions. Take this example. If we were to order these fractions in ascending order, students should be given the opportunity to create the most appropriate equivalent fractions in order to write these 3 fractions in ascending order. Starting from the largest denominator, equivalent relationship can be created with a denominator of 8. The students can then be prompted to ask themselves the question, what can I multiply the 4 in the denominator of 3/4 by to give me 8? And what can I multiply the numerator of 3/4 to give me the equivalent fraction of 3/4? If I multiply the denominator by 2, then I need to multiply the numerator by 2 also. This will provide the equivalent fraction for 3/4. Teachers would also encourage the students to do the same with a half. The same questions can be asked. What do you multiply the denominator of a half by to give me 8? And since we multiply the denominator by 4, we need to multiply the numerator by 4 to get the equivalent fraction. Now that all the fractions are of the same family, an ordering can take place. The ordering, therefore, will start from the lowest to the highest, the lowest being 3/8 and the highest being 3/4. Keep in mind that though we can use the same family to order, teachers must encourage their students to put back the original fractions that were given. Additionally, teachers can make it easier for students by providing number lines that already was calibrated. For example, the teacher can initially provide a number line from 0 to 1 but subdivided into 8 equal parts. Doing this will help the students to discover easily how these numbers are written on the number line. If this is the whole 0 to 1, the teacher would segment it into 8s like this, and the students will insert the given numbers expressed in ascending order on the number line like this. Whereas teachers should initially do this for their students, teachers are encouraged to eventually let the students draw their own number line and have them calibrated on their own. Keeping in mind that the major component of constructivism is self-discovery, students should be encouraged to discover the meaning of numerator and denominator on their own. The teacher can display 2 tiles like this, 2 1/3 tiles, and ask the students the following questions. What fraction is represented here? And how do you know that it's 2/3? How many thirds does 2/3 have? And how many thirds are in a whole? These questions can be repeated for other fractions. Then you can ask them, what does the numerator tells us? And what does the denominator tells us? After going through all these questions, the students will observe from the questioning a meaning for numerator and a meaning for the denominator. Teachers can provide the necessary guidance as they see it fit. The numerator tells us the number of equal parts we have displayed, and the denominator tells us the number of equal parts that are in the whole. These must be measured against the student's response. and the teachers will guide the students accordingly to solicit the response that is needed. It cannot be overemphasized the importance of having students discover the meaning of these terms on their own. The teacher, however, are facilitators. They can facilitate the learning. The teacher can use the fraction tiles and place them in an arrangement like this, having been aligned leftmost, so that each of the unit tiles would be matched against the whole. After doing this, the teacher would ask the students to do the same. And using their fraction tiles, the teacher can ask the following probing questions. What do you notice with respect to the size of the proper fraction tiles when it compares with the whole? How do you compare the numerator and the denominator of each fraction? Do you think if we had a tile that was larger than the whole, would it be a proper fraction? Why do you think so? These questions would help the students draw out the information that is necessary to create the definition for a proper fraction, simply because it will give the attributes of a proper fraction. In answering the first question, the students will notice that the whole is larger in size than the unit tiles. Also, the answer to the second question would give the students an understanding that the numerator of a proper fraction is less than the denominator of a proper fraction. Just these two attributes can give you the definition of a proper fraction. That is, it is part of a whole and it has a numerator that is less than the denominator. A similar approach can be taken to determine the meaning of an improper fraction. The teacher can also guide the students by having them place 3 halves and match it against a whole. Then the following questions can be asked. How many halves make one whole? How many halves are represented here? How can we represent 3 halves? How does 3 halves compare with the whole? Is it a proper fraction? How do we know? And if not, what type of fraction do you think it is? The answers to all these questions, again, will give you the attributes of an improper fraction. That is to say, an improper fraction would be greater than a whole number, and the numerator would be greater than that of the denominator. The students can now write the definition for a proper fraction. This same example can be used to illustrate the meaning of a mixed number. This is because when we use this, we can see we can get one whole by matching the fraction, since 2 halves is equal to 1 whole, with a remaining half left over. Teachers again can guide the students to formulate their definition for a mixed number. Teachers can go one step further by representing this number on the number line. Here we have a whole being between 0 and 1, and another whole being between 1 and 2. But since we have 3 halves would be equal to the midpoint between 1 and 2. Teachers should also be mindful that they can represent this 3 halves using concrete objects. For example, they may use a set of marbles. If this represents the whole, then 3 halves would be equal to 1 whole plus a half. That is 3 halves. Having done this, we can recall that these would represent all 3 set models. The first being the area model, the second being the linear model, and the third being the set model. To express improper fractions as a mixed number, teachers should encourage their students to use the CPA model as well. Starting with the concrete, the teacher can display 3 halves juxtaposed against a whole and ask the students to do the same. Then the teacher can ask probing questions such as how many halves are there in a whole and how many halves are remaining. This is because when we add 2 halves to 1 half, this would give us the 3 halves. Taking the 3 halves, we can see out of the 3 halves, we can see that 2 halves is equal to 1, and you will have remaining a half. 1 plus a half is 1 1/2. Teachers will then be encouraged to do 3 to 4 more examples before moving on to the pictorial representation. In the pictorial representations, students will replicate the exact concrete experience they had as your picture to do the same problem. Then they would look at the questions, the pictures, and the answer and look for a pattern. The pattern therefore would help them develop the algorithm for changing an improper fraction to a mixed number. In this case, you simply divide the numerator by the denominator and put the remainder over the original denominator. Now the students are ready to do the same process but in abstract form. That is, they will use the algorithm to convert the improper fraction to the mixed number. Here is the same example. 3 halves will be equivalent to 3 divided by 2. But when we divide 3 by 2, we will get 1 remaining 1. The 1 represents 1 whole, and the other 1 represents the 1 to the numerator, or 1 part of the fraction, and the number of parts in the fraction would be 2. So 3 halves would be equivalent to 1 1/2. Teachers must be encouraged to use the CPA model to teach the addition and subtraction of fractions of similar denominators. Starting with the concrete, the teacher will encourage the students to model the problem where they will place 3 of the 8 tiles and 1 of more 8 tiles to get a sum of 4 8s. Teachers must also provide at least 3 more examples so that the students would get a hang of it. Now that they have gotten a hang of it, they will move on to the pictorial representation, where the same examples that were used at the concrete stage is used in the pictures. And the students would then look at the questions, the pictures, and the answers, and from looking at them, they would have observed a pattern. The pattern observed is the process for which the addition is done. This process, therefore, formulates the procedural aspect or the algorithm for adding the fractions. This is used at the abstract stage where students will use the algorithm to complete the addition of the fractions. Subtraction will be done in a similar vein, where students would model the problem, keeping in mind that subtraction means the removal of, so the student will remove one of the 8 to obtain the answer. Students also should be encouraged to find equivalents to 2 8s, or to reduce the 2 8s first by using the concrete means. The students will place 2 8s and find the appropriate unit fraction tiles that tessellates to 2 8s. In this case, we will have 1/4 or a quarter. The teacher will then provide 2 or 3 more examples before moving on to the pictorial stage, where they will make their observation and then proceed to the abstract stage. In this case, the abstract stage would simply be the algorithm for subtracting fractions with similar denominators. That is to say, we subtract the numerators and keep the denominators. This is the end of the video. Please don't forget to like, share, and subscribe.